Hey, welcome back. So we're going to continue our review of series day 1, and we're going to do question number 9 for us. This is a question directly from the AP exam, so let's go ahead and get started on it. So the function f has derivatives of all orders for the real numbers x. So they're telling us that it has derivatives. Assume that the value at 2 is equal to 3. So what are they telling us here? Well, they're giving us the initial condition at 2 is 3. So when we write our Taylor series, or polynomial in this case, that's giving us our first term. And they tell us the first derivative, the second derivative, and the third derivative. They want to write a third degree Taylor polynomial for f about x equals 2 and use it to approximate f of 1.2 here. So for part A, when I write my Taylor polynomial, it's a polynomial, so remember there's no plus ... it's just going to be P3 third degree of x equals. Now you could say let f of x approximate, and that'll be okay, but do not put f of x equals, because that means it is a, here you're saying the function. To get the function, we have to write a series. We would need that plus ... So keep it as a polynomial, it's best to keep it P3 of x. And what's this going to be? Well, my first term is 3, and now I'm going to generate my Taylor the rest of them, because for n is 0, they tell me it's 3, but for n is 1, 2, and 3 here, looking at the degrees, we have to use our Taylor. And remember, our Taylor polynomial rule is the nth derivative of c over n factorial times x minus c to the n. Now what they're giving us is the value of the nth derivatives. So when I let n equal 1, my first derivative here is negative 4. So this is going to become minus 4 over n factorial, 1 factorial, x minus 2, because there's my center is 2, to the first. Let n be 2, same thing, n be 2, they're telling me it's negative 1, so it becomes minus 1 over n factorial, which is going to be 2 factorial, x minus 2 squared. And then the last one for 3, and that's plus 5, remember n is 3 here, over 3 factorial, x minus 2 cubed. And there is our third degree Taylor polynomial. Now they want me to use that to approximate the value at 1.2. So we can say P3 of 1.2, which is about the same as the value of 1.2, which we can say is going to be 3 minus 4 over 1 factorial. Plug in the 1.2 here, that becomes negative 0.8 to the first minus 1 over 2 factorial, negative 0.8 squared plus 5 over 3 factorial, negative 0.8 cubed. And you can leave your answer like this. All right, so for part B says the graph of the fourth derivative is shown here. And they tell us that we have a horizontal tangent down here, so there's my horizontal tangent right here. And they say use Lagrange error bound to show why the approximation at 1.2 is, and then to use that to explain why the answer could not be 5.3. So let's go ahead and find our maximum error. So we're going to be using Lagrange. So what does Lagrange say? To get the error in my third term, that's going to be less than or equal to my fourth term. But remember, in Lagrange, we don't know the fourth term, so we have that rule. That becomes the value, the maximum value of the fourth term, fourth derivative over 4 factorial. And in this case, it will be 1.2 minus 2 to the fourth. Now remember what this says. This says what is the maximum value, right? We want the max value of the fourth derivative. And I can get that by looking over here. Well, here's my fourth derivative on my domain, 1.2 to 2. The maximum value is at 1.2. So the value there is going to be 3. So we can get 3 over 4 factorial times negative 0.8 to the fourth. Now I typed this in my calculator earlier, and we get 0.0512 by Lagrange error bound. Right there. Now, what does this tell us? Well, remember, what this 0.0512 tells us is that this is the maximum value that we could be off for our actual answer. So let's go ahead and do part C now. Part C says to write a fourth degree Taylor polynomial for the function g of x equals f of x squared plus 2 about x equals 0. Use P to explain whether g is a relative minimum, a relative maximum, or neither. So what we're going to do, well, we know that g of x is equal to f of x squared plus 2 about x equals 0. So this is centered at 0. Now remember, our first function was centered at where? At 2. Where was it at? Oh, there it is, centered at 2. So what this does for us is it shifts us to the left 2 units, which is going to kind of make this more of a Maclaurin polynomial. So I can now rewrite my new polynomial, p of x equal to 3 minus, this is just 4 really, this becomes, replace this as x squared plus 2 minus 2 to the first, minus 1 over 2 factorial times x squared plus 2 minus 2 squared and so on. And I can do the next one. So, and let me do one more here. Let's go do the last one here. Plus 5 over 3 factorial x squared plus 2 cubed. Now remember, they only want a fourth degree Taylor polynomial. So if I cancel these out, what I'm left with here is 3 minus 4x squared minus 1 over 2 factorial. And over here, those cancel. That gives me x to the fourth. So there is my fourth degree polynomial right there. Because remember, we only wanted a fourth degree Taylor polynomial. So that's good. But now they say, use this to explain whether g of x, the function g, has a relative maximum or minimum value. Well, now I can use my derivative test. Right here. The derivative at 0, so I can say g prime of 0. Well, remember, there is no 0 factor right here. There's nothing with a 0 right here. So that's going to be 0. So therefore, x equals 0 is a critical number. And I can use the second derivative test. Well, what is the second derivative at 0? Well, to do that, I have to look over here, and I'm going to use my Taylor polynomial. Remember this negative 4. X squared has to equal the second derivative at 0 over 2 factorial times x squared. My polynomial, those cancel, and I'm left with my second derivative has to be this negative 4 times 2 factorial, which is less than 0, so therefore this is concave down. So we have a critical number that's concave down, so this is a relative max. Therefore x equals 0 is a relative maximum, and this is our second derivative test. Second derivative test. Most people probably have a hard time with it. That one's a pretty tricky one there to do. Alright, so I hope you enjoy these videos. I will see you all later. Bye-bye.